Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the PSSA big ideas on proportional relationships. And then we will also get to the one on percent. So let's start with the idea of unit rate. A unit rate is a rate where the denominator is 1. For example, $25 per hour really means $25 for every 1 hour. And if you would write that ratio as a fraction, that would be $25 over 1 hour. And so you can see the denominator here is 1. And anytime we talk about a unit rate, which very commonly will use the word per, such as per hour or per ounce, or per foot, or per second, or whatever it might be, whenever we talk about unit rates, using the word per, if you would write it as a fraction, the denominator would be 1. Now, this directly ties in with the idea of proportional relationships. Proportional relationships are the kind of relationships where two quantities are going to be proportional if there is a constant ratio between them. And it just so happens that the constant ratio could also be described as a unit rate. So from our previous example, where we talked about how it was $25 per hour, here we have a table with hours for the first row and the pay in dollars for the second row. And if you would set up the ratios, putting the dollars in the numerator and the hours in the denominator, so that way you get the dollars per hour. You wouldn't do it the other way. If you put the hours in the numerator, then you would get hours per dollar, which really wouldn't make any sense. So anyway, if you put the money in the numerator, which is very normal, and you divide by the number of hours, you would get $25 per hour for all 4 columns in this table. And you can see there is a constant ratio of $25 per hour. And since there is a constant ratio, this means that this relationship here is a proportional relationship. Now, there are 2 very important things we can do with proportional relationships. We can write an equation to describe a proportional relationship, and we can also graph the proportional relationship. Let's first talk about the equation. The equation for a proportional relationship is going to be in the form of y equals kx. Now, what that really means is you're going to have a variable set equal to the unit rate, or also known as the constant ratio. It's generically called k here, and that k will be multiplied to another variable. For example, if you look at our previous example, we were talking about how we are being paid $25 per hour. The word per often can mean multiplication. So $25 per hour means $25 times the number of hours, and that is equal to our pay. And so you can see this is in the form of y equals kx, except we rarely ever use y and x. I mean, I shouldn't say rarely, but it's usually more helpful if you use variables that apply to the problem that we're talking about. So if we're talking about the amount of pay, we could use P. If we talk about the number of hours, we could use H. So we don't always have to use generic Y and generic X. We definitely can use variables that make a lot more sense for the problem. And then let's talk about the graphs of proportional relationships. As we learned earlier this year, a proportional relationships graph will always be a straight line, and it will always pass through 0, 0. Those are 2 huge properties of proportional relationships graphs. And if you look at the examples here, the example here from the same chart we were looking at earlier, if I would graph that chart and make 3 dots, those 3 dots would form a straight line. And if you extended that line, you would see it's going to pass through the origin, which is 0, 0. So this is what we're talking about here. Every single proportional relationship, when graphed, if you would connect those dots with a line, it would be a straight line, and it would pass through 0, 0. Now, there's something else that's also very important about unit rates and proportional relationships. Remember back how we talked about how unit rates always have a denominator of 1? Well, let's apply that now to graphs. We can actually find the unit rate on any graph of a proportional relationship by going to the ordered pair where the x value is 1. I hope you remember that with ordered pairs, the first number is always the x, and the second number is always the y. And on a graph, the x-axis is the one that goes right and left. The y-axis is the one that goes up and down. So if you go to the x value of 1, which on this graph would be halfway in between 0 and 2, if you go to that point, look what it is, 25. This should not shock us. This table had a constant ratio of $25 per hour, which was the unit rate. Do you see how all these things tie in together? I hope you do. That's why I put them all on one page. So this is why for a proportional relationship, if you go to the ordered pair where x is 1 and you find the dot at that place, you will have the unit rate. Like we said, when x is 1, the y value is 25. That represents $25 for 1 hour, which is the unit rate that I've been using over and over again for the examples of this page. Now, one more thing, and this does tie in with proportional relationships. A proportion is also something that can be used with proportional relationships. And whenever I say a proportion, I'm talking about two fractions set equal to each other, where each fraction represents a ratio. And whenever you have a proportion where you have a fraction set equal to another fraction, you can use what is called the cross products rule, which says that if two fractions are equal, and this is huge, it's got to be an equal sign in between. If it's anything else in between, then you cannot do cross products. But if there is an equal sign in between, then their cross products will also be equal. So for example, if somebody was paid $150 for 6 hours of work, how much is this person going to make in 10 hours? So we can say $150 over 6 hours equals X dollars over 10 hours. And then what we could do is we could cross multiply to solve, and then eventually solve for X. We could take 10 times 150, 6 times X, and then from there we get to solve for X by using inverse operations, because we're going to have 6X. So we'll eventually divide by 6 on both sides. And so that's what we call a proportion. And the cross products rule is one way, a very easy way, of getting started on solving proportions. All right, so let's do a practice problem. I want you to do this on a separate sheet of paper. You do not have to copy down the problem. Please don't even try to copy down the graph. That would just take way too much time. I just want you to take a look at this problem and try it on your own. It says the hardware store sells nails by the pound. The graph represents the price of nails at the store. And the question is, what is the unit price of nails at the hardware store? Hit pause on the video, figure out what the answer is, and then hit play when you're ready to see how you did. Okay, I hope you remembered that with proportional relationships, you can find the unit rate, and in this case, it's called unit price because there's money involved. Still the same idea of unit rate, though. And you can find a unit rate on a graph when you find the x value of 1 and you go to the dot that would be at that location. Now, you can see this would be a little bit higher than $2, but it's not at the halfway point between $2 and $4. It's a little bit under that $3 mark. So makes sense to me. This is probably somewhere around $2.50 or $2.75, and it just so happens choice B then is the choice that does make sense. Now, if you're not sure when you were looking at the graph if this was going to be $2.50 or $3, another thing you could have done is you could have said, whoa, this place right here, the line goes through the grid lines perfectly, and so I know that this is $10 for 4 pounds. Well, if you take 10 and you divide by 4, guess what you get? You're going to get $2.50 per pound. So that's another way that you could have confirmed that it was $2.50 per pound and not $3 per pound. So that's something that would work. And that's the idea of dividing to find the unit rate. All right. Now, this next problem is not multiple choice. Again, I want you to read this to yourself and try it on your own. So hit pause on the video, try this on your own. There is some work involved. Then hit play when you're ready to see how you did. All right, so we have this chart here, number of scoops and the area of ground to be covered in square yards. and they want us to find the constant of proportionality. Perhaps I should have put this on the review sheet. Constant of proportionality is a phrase that means the exact same thing as constant ratio. It also means the exact same thing as the unit rate. So, if you recall from the Big Ideas paper that I was just looking at, the idea of setting up each ratio and dividing to get the unit rate, which is the constant ratio, this is the kind of work that we can do for this problem. So if you were stuck and you now know what you need to do, now feel free to hit pause then again if you need to, and then hit play after you've completed your work. So you're going to say 50 square yards over 2 scoops. You wouldn't do 2 scoops over 50 square yards because then that'd be scoops per square yard. It probably makes more sense to say the amount of square yards per scoop. That seems to make a lot more sense. And so we'll continue to do that. 100 over 4, 150 over 6, 200 over 8. If you divide, you're going to get 25 square yards per scoop. And that's going to continue. That is your constant ratio, which is another way of saying the constant of proportionality. And so that's the answer. That's our constant of proportionality. Now, let's say this is a part B. It says the field Archie will cover with grass seed is rectangular and measures 100 yards long by 60 yards wide. I want you to write an equation that describes the relationship between the number of scoops, we're going to call it X, of grass seed needed, and the number of square yards, we'll call it Y, of ground to be covered. Use the equation to determine the number of scoops of grass seed Archie needs to cover the entire field. So this is actually a two-part problem. I need you to write the equation, and then I need you to use that equation to find the number of scoops of grass seed that Archie needs to cover the entire field. Remember, it showed you above what the measurements were for the field. So hit pause on the video, do the work, and then hit play when you're ready to see how you did. All right, I hope you have already done this on your own. The very first thing I would do is I would take those measurements of 100 yards and 60 yards, and I would find the area. And since it is a rectangular field, then we're going to use the area formula of a rectangle, which is really simple, something you learn in elementary school, length times width. So 100 times 60 means it's going to be 6,000 square yards that we have to cover. Now, this does not answer the question yet. This is just the beginning piece of work that I need to do. I need to now write the equation that describes the relationship between the number of scoops and the square yards of ground to be covered, and we're using X to represent the number of scoops of grass seed and Y to represent the square yards. How am I going to write this equation? Well, if you go back to the Big Ideas paper, you will remember the type of equation that we use, where it's some variable equals the constant ratio times the other variable. And so on our problem, we had 25 square yards per scoop, which means times the number of scoops. So I need to have 25 times the number of scoops, which we called X, and that's going to equal the square yards that need to be covered. And now that I have that equation, by the way, that's the first thing I would arguably circle, because that's one of the things the directions asked me to do. Write the equation. So there I did it. There's my equation. And then I'm going to use that equation to determine the number of scoops of grass seed that Archie needs to cover the entire field. I know that the entire field is 6,000 square yards. But which variable do I put that in for? Well, look back at the paragraph. Which variable is the square yards? It is Y. So that 6,000 needs to go in for the Y. So if I substitute Y with 6,000, then to solve for X, which is the number of scoops, and by the way, that's what the problem wanted me to find, was to determine the number of scoops of grass seed. So that's my X. So to solve for X, I have to use inverse operations because the X was being multiplied by 25. So I'm going to divide by 25 on both sides. And that's going to give me 240. 240 what? 240 scoops of grass seed. And there you go. That is the last part of this problem that it wanted me to figure out. All right, let's continue to the second page, and this might be on the back of your paper if you got it from me. If you printed it out from home, then maybe it's just your second page. And this goes along with proportional relationships, but it's going to be specifically on percent. What does percent mean? Well, percent means out of 100. It is that very specific ratio. Now, percents can be written in fraction form. You'll just put the percentage number over 100, and then you could possibly reduce. Or it can be written in decimal form using the hundredths place value of after the decimal point. So for example, if it's 24%, that could be 0.24, because if it's 0.24, that's 24 hundredths, and that's what percent means, out of 100. All right. You heard me earlier this school year talk about the base. Now, a lot of textbooks a couple decades ago used to also use the word base, but since then I've noticed a lot of textbooks across America have changed and have used the word whole. And when I say whole, I don't mean a hole in the ground, I mean W-H-O-L-E. So this is kind of a synonym for what I call the base. Anyway, the base or the whole amount refers to the total amount that the percent is taken of. And we learned earlier this year that the word of is a very important word to keep in mind whenever you're trying to identify the base. For example, 25.6 is 80% of 32. So what's the percent being taken of? The percent is being taken of 32. So 32 is my base. Or you sometimes will see the phrase out of. If you see something like 12 out of 48, then 48 is your base. And by the way, 12 then would be your part. So something we talked about earlier this year. And speaking of part, this brings me to the two different ways that we learned how to solve percent problems. Percent proportion, which is the part over the base, equals x over 100, where x over 100 represents the percent. Remember, percent means out of 100. Or the method that most of the time people tend to use, because it honestly is usually quicker and easier to use and just more practical in many situations, is what we call the percent equation, where you take the percentage rate times the base, or some textbooks call it the whole amount, and that will equal your part, or whatever you're trying to solve for. And so that's the formula of part. By the way, capital P here does not represent the percent. Capital P represents the part, equals the percentage rate times the base. And the percentage rate is going to be the percent in decimal form, maybe fraction form, but usually it's easier to put it into decimal form. So let's look at a practice problem that deals with percent. Kelly has a savings account with a beginning balance of $800. She earns $340 a week at her job. For 8 weeks, she puts 15% of her weekly earnings into the savings account. Kelly makes 3 withdrawals of $45 each. What is the account balance at the end of 8 weeks? This is definitely a multi-part problem. All right, some work needs to be done. Obviously, you can use your calculator as well to help you, but show your work. Hit pause on the video, do the work to figure out this problem, then hit play when you're ready to see how you did. Okay, I hope you have already done this on your own. First thing I want you to notice is that it says 15% of, remember how we talked about that whenever you have a percent followed by the word of, the very next thing will be your base. So 15% of what? Of her weekly earnings. Well, what was her weekly earnings? Oh, they tell you that at the very beginning. $340 every week is what she is earning. So we need to take 15% of $340. But we also need to take that times 8. Why? Because the second bullet point here said that she's doing this for 8 weeks. So if you take 0.15 times 340 and then times 8, you would get $408. And by the way, a couple different ways of doing your work here. Some kids would do 340 times 8 first. Other kids might do 0.15 times 340 first. Commutative property multiplication. The order really doesn't matter for your multiplication here. Now, from here, remember how there was a beginning balance? The beginning balance was $800. So this $408 that she was putting into her savings account for 8 weeks straight, that has to be added on to the $800. So that means she had $1,208 in her bank account. But there's another piece of information here. It said in the third bullet point that she makes 3 withdrawals of $45 each. The word withdrawal means taking it out of the bank account. So 3 times 45 would be 135. But we have to take that out of the bank account, which means it's going to be subtracted away from the $1,208 that we had after the 8 weeks was done. So if you take 1,208 and subtract by $135, you will get $1,073, which happens to be choice C. All right, going back to the big ideas paper on percents. About halfway down on the page is a section that talks about markups and tax and markups and discount. What you should remember is that if you want to find the final price and you have an original price involved, then the way that this works with markups and tax is that the original price is 100% of itself, and if you add it by the percent of markup or the percent of tax, this will give you the percent that you end up paying. Now you'll put it in decimal form, and that will go in for the percentage rate. If you take that times the base, and the base needs to be your original price before the markup or tax was applied, so whatever that original price was, times the percentage rate will give you the final price. Now, that same idea can be used with markups and discount. All right, the part here would be the final price. The percentage rate is still going to be multiplied to the original price. And when I say the original price, I mean the price before the markdown or discount occurred. But with markups or discount, what you need to realize is that it's going to be 100% minus the percent of markdown or discount. And that's going to give you the percent that you pay, and then you'll put that in decimal form for the percentage rate. So, bottom line, it's going to be 100% plus the markup or tax percent, if it's markups or tax. But if it's a markdown or discount, then that comes off the original price. So it's going to be 100% minus the percent of markdown or discount to give you the percent that you pay. So, normal example, in Pennsylvania we have 6% sales tax. That means you would pay 106% of the original price after the sales tax has been applied. But for discounts, if it's a 20% discount, you will pay 80% because 100% minus 20% means you will pay 80% of the original price to get your final price. Couple more things you need to talk about percent. Percent of change means the percent that an original amount increases or decreases to get to a new amount. If you have to find the percent of change, then you can use a fraction where your numerator is the amount that it changed by, whatever that amount was, and then divide by the original older total. That's going to give you a decimal. Then you can convert it to a percent by just moving the decimal point 2 places to the right. The other thing I need to tell you or remind you about with percent is the simple interest formula, which is I equals PRT. Now, I represents the interest, which is the extra money earned or paid. P is the principal, which is the original amount of money that we save, invest, or borrow. And then R is the interest rate, which kind of like capital R is the percent in decimal form. T is the time, and it must be in years. So anytime you have a problem talking about interest or the amount of money that you save, invest, or borrow, and the interest that you have to earn or pay, this is the formula that you will use. All right, so here's another practice problem. It says a club plans to spend no more than 85% of the $1,200 in its activity budget to buy as many radio-controlled helicopters as possible. The price of a helicopter is $110.99 plus sales tax of 6%. What is the greatest number of helicopters the club can buy? Okay, hit pause on the video, do the work, and figure this out on your own, and then hit play when you're ready to see how you did. All right, first thing you should notice is that it said the phrase no more than, which is an inequality symbol. No more than means it can't be more than, which means it could be less than or equal to. Now, less than or equal to what? 85% of the 1,200. So that's 85% is 0.85 or 85 over 100 of the 1,200. So that's going to be mean times the 1,200. If you use your calculator, that means they want to spend less than or equal to, which means no more than, $1,020 for all these radio-controlled helicopters. Now, we need to find out how much is each of those radio-controlled helicopters. Well, it said $110.99 plus sales tax, and the sales tax was at a 6% sales tax rate, very similar to Pennsylvania. So, as I taught you earlier, for sales tax, you can get the final price of the item if you take 100% plus the percent of tax and then put that in decimal form and multiply it to the original price. So 100% plus 6% would be 106%, which means you can take 1.06 times $110.99, and that will give you about, you have to kind of round to the nearest cent here, $117.65. Now, if you don't want to do 1.06, there is another way, but it takes two steps, and that is you would take 0.06 times $110.99. That's going to give you the dollar amount of tax. Then you would have to add it back on to the $110.99, and you would still get the same answer that I have here of $117.65. But to me, that's the long way. It's so much quicker to me to understand that when there's 6% sales tax, you're going to pay 106% of the original price. So that's why it is used 1.06 for 106% and multiply that times the original price. I find that to be a lot quicker. Now, we're not done. We have to find the greatest number of helicopters that the club can buy. So we can take the total amount that they are willing to spend and divide by the price of each of those helicopters. But remember, they want to spend no more than the $1,020. So that's less than or equal to. I'm going to keep that in mind. So if I divide, I'm going to get 8.6697, yada, 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 yada. Now, should we round that? Well, you need to remember the phrase no more than. They do not want to spend over this amount of $1,020, which means they do not want to buy more than 8.6 yada, yada, yada helicopters. So even though 8.6 would round up to 9, we're not going to do that. We want to spend less than or equal to the 8.6. So the greatest whole number that is less than or equal to 8.6 would be 8. So if you thought it was choice B, I am sorry, that is not correct. If you would do 9 helicopters, you would spend more than $1,020, which goes against what the first sentence said. They want to spend no more than 85% of the $1,200. So you cannot go over the 8.6. This is why it has to be 8. And that concludes the video that reviews proportional relationships and percent. Thank you for watching. We'll see you next time.